Welcome students, good morning. Welcome again into the 12th Science Chemistry class. Today we are going to learn the hydrolysis of salt. This is the topic of chapter number 3, that is the ionic equilibrium. Now what is in this hydrolysis of salt? How the salts are hydrolyzed? Yes, salts get hydrolyzed. Now hydrolysis of salts mean when salts reacts with the water, that is hydra. That means the ions of the salts, cations and anions get hydrolyzed with the ions of water, that is the hydronium ion and hydroxyl ion. So due to that is hydrolysis, or due to this reaction, the solution of salts and water may have sometimes acidity or basicity or even neutrality, and such process is called as the hydrolysis of salt. Now see here how the hydrolysis of salt is defined. Hydrolysis of salts. It is defined as the reaction in which cations or anions, that means positive ions or negative ions, or both the ions of the salt react with ions of water. So hydrolysis is defined as the reaction in which the cations, that is positive ions or anions or negative ions, or both the ions of the salt reacts with ions of water to produce acidity or alkalinity, that is basicity, or sometimes even the neutrality. This reaction is called as hydrolysis of salt. Remember students. So in hydrolysis of salt, the cations or anions or both the ions of the salt reacts with the ions of water. The ions of water are hydronium ion and hydroxyl ions to produce acidity, alkalinity or even neutrality to the solution. This process is called as the hydrolysis of salts. Now there are 4 types of salts are present. Types of salts. There are 4 types of salts. Now how are that 4 types? Salts derived from strong acid and strong base. That means the salt which are formed due to the reaction between strong acid and strong base. We know that in the neutralization reactions there is formation of water and salt when acid and base reacts with each other. Now during that neutralization, the salts which are derived from the strong acid and strong base are called as the salts of strong acid and strong base. And the best example is NaCl, sodium chloride. Now how this sodium chloride is formed? The strong base, that is NaOH, sodium hydroxide, when reacts with strong acid, that is HCl, hydrochloric acid, then there is neutralization between them and there is formation of this NaCl and H2O water molecule. You very well know this reaction into the previous standards. Now how that neutralization reaction? See here, this NaOH plus HCl on neutralization give NaCl and water. Now see here, this Na cation and this is chloride ion forms the salt NaCl, and this H and OH form the water. So this NaCl salt, that is the sodium chloride, which is the table salt, is This sodium chloride is the salt derived from, that is, strong acid and strong base. So that is the example NaCl. Now another example of salt of strong acid and strong base is Na2SO4. We know that H2SO4, that is the sulfuric acid, H2SO4, when reacts with, that is the NaOH, 2 moles of NaOH when reacts with the H2SO4, because there are the 2 hydrogen atoms in the H2SO4. So it requires the 2 molecules of NaOH. So they form similar reaction will be there. Now twice NaOH plus H2SO4 here, and that H2SO4, and these are the twice NaOH, strong acid and strong base. There is formation of Na2SO4 because SO4 have the -2, that is the charge on that ion. So it requires 2 Na. Na have only 1 Na plus, that is the charge. So Na2SO4, and these are these 2 hydrogen ions and 2 hydroxyl ions forms the 2 water molecule. Now this is also the salt of strong acid and strong base, that is the sodium sulfate. Now this sodium sulfate, again sodium nitrate, HNO3, nitric acid, which is the strong acid, and NaOH. So NaOH and HNO3 form the NaNO3, which is the salt of strong acid and strong base. Nitric acid is the strong acid and NaOH is the strong base. Now next is the KCl. Here also KOH, potassium hydroxide, which is the strong base, and HCl, that is the strong acid. So KOH plus HCl from the KCl and H2O, and this KCl is also the example of the salt of strong acid and strong base. Now next type of salt is the salt derived from strong acids and weak bases. Strong acids and weak bases. Now here acid is strong but base is weak. Such type of salts which are derived from the strong acids and weak bases are called as the salts of strong acids and weak bases. Now the best example is NH4Cl. Now we know that NH4OH, ammonium hydroxide, NaOH is the strong base, but NH4OH, ammonium hydroxide, is the weak base, and HCl, hydrochloric acid, is the strong acid. So salt of strong acid HCl and weak base NH4OH form, which is the NH4Cl. Here is NH4OH, here is HCl, and there is formation of NH4Cl, which is the salt of strong acid and weak base, ammonium chloride. Now this ammonium chloride, we are familiar, very well familiar about that. That is the ammonium chloride. Now next one is the copper sulfate, is also the salt of strong acid and weak base. Sulfuric acid, H2SO4, is the strong acid, and CuOH twice, that is the copper hydroxide, which is the weak base. So CuSO4 is the salt of, that is, strong acid and weak base, copper sulfate. Next one is the ammonium nitrate, NH4NO3, HNO3. Nitric acid is the strong acid and NH4OH again is the weak base. So NH4OH, ammonium nitrate, is also the salt of, that is, derived from strong acid and weak bases. Now next type of the salts are salts derived from weak acids and strong bases. Now acids are weak here and bases are strong. Now weak acids we know, that is the hydrogen cyanide is the weak acid. Carbonic acid H2CO3, which is the weak acid. Again that is the H2S is also acts as the weak acid. So see the salts of weak acid and strong bases on the blackboard. Now see here, this all the organic acids are weak acids again. Acetic acid, formic acid, butyric acid. So when these organic acid reacts with the strong bases, they form the salt of weak acid and strong bases. Now this sodium acetate, we always read the that is the salts. Now see students, this is the that is sodium. Always read the salts which are derived from the organic acid from backside. This is sodium acetate. Now here is the NaOH is the strong base and acetic acid CH3COOH is the weak acid. So when acetic acid reacts with NaOH, there is formation of CH3COONA and H2. So it is the salt of strong base and weak acid. The next is KCl, potassium cyanide. In that, this KOH is the strong base and HCl, as I told you, that is the hydrogen cyanide, is the weak acid. We are seeing the salts of strong base and weak acid. So KOH is the KOH plus HCl. There is formation of KCl plus H2O. Again Na2CO3, sodium carbonate. Now here NaOH is the strong base, but H2CO3, carbonic acid, is the weak acid, and the salt which are called from salt, that is the salt of strong base and weak acid, and this is the Na2CO3, sodium carbonate. Now four types of salts are salts derived from weak acids and weak bases. There are the four types of salts derived from weak acid and weak bases. Now for example, this ammonium acetate, NH4OH is the weak base and acetic acid is the weak acid. So ammonium acetate is the salt of weak base and weak acid. Now let us learn more information about the hydrolysis of water, hydrolysis of salt. Now concept of hydrolysis. When a salt is dissociated in water, it dissociates completely. Remember that, as that of the strong acids and strong bases, which are 100% dissociated, completely ionized. In the similar manner, all the salts, they may be all these four types of salts. All the salts dissociate 100% completely. Remember that, students. So when a salt is dissociated in water, it dissociates completely into its constituent salts. The solvent water dissociates slightly, as H2O liquid plus H2O liquid gives H3O plus aqueous plus OH minus aqueous. Now there is formation of hydronium ion, and that is the H plus ion. We know that are the similar, but this hydronium ion is formed when these two reacts. Two water molecules, and there is the hydroxyl ion is also. Pure water is neutral. Now when H2O plus is equal to OH minus, in the pure water always the hydronium ion and the hydroxyl ion have the same concentration. So if the ions of the salt do not interact with water, the hydronium ion and hydroxyl ion concentration remains constant always. If there is not that is the interaction between the ions of the salts and ions of water, then there is always this hydronium ion concentration is always equal to that of the hydroxyl ion concentration. Now this is about the hydrolysis of salt, students. Now let us learn more about this the hydrolysis of the salt again. Now what is again into the hydrolysis of salt is given, let us learn. So students, if there is no interaction between the ions of water and ions of salts, then the concentration of hydroxyl ions and that of the hydronium ion remains constant, and the solution does not neutral or become acidic or basic depending upon the type of the salt. Such reaction between the ions of salts and water is called as the hydrolysis, and then you can write again the definition of hydrolysis, that is hydrolysis of salt. It is defined as the reaction in which If the solution have the salts such as strong acid and strong base, then there is completely dissociation of the ions, and the hydroxyl ions and the hydronium ions have the concentration similar or constant. So the solution which is formed due to the hydrolysis of strong acid and strong base salts or salts of strong acid and strong base, it is always neutral, because into that there is the concentration of hydronium ion and hydroxyl ions are nearly similar. But if there are the salts such as salts of strong acid weak base, salt of weak acid strong base, in that cases the that is the proportion of hydronium ion and hydroxyl ions are not equal or constant or same, and in that cases, if the concentration of hydronium ion is greater than the hydroxyl ion, that is the H plus ion is more than the OH minus ion, then definitely the solution attain the acidity or the solution is acidic. But if opposite is the case, if the hydroxyl ions are greater than the hydronium ion, then definitely the solution is the basic solution and it acquires the basicity. And the salt of weak acid and weak base, that depends upon which is slightly stronger. The weak acid is stronger or weak base is stronger, on that the solution depends the acidity or alkalinity. Now this is about the hydrolysis of salt, student. If you understand very well the definition of hydrolysis of salt and which are the types of salt, that is 4 types of salt, you may like, subscribe and share this video to the other students so that they also have the benefit and they get advantage to write down confidently the answers of the questions in the examinations. So best of luck. Thank you for watching this video. Subscribe. Thank you. Students, you may take the screenshot of this blackboard writing and write down notes in your notebook, which is very important for your all examinations. So you must write down the notes in a beautiful handwriting. Thank you, students, again.